All right, let's look at the second part of our 5.2 video here. We're going to talk about slope. That's an important concept. We will talk about finding slope from a graph. We will talk about finding slope given just 2 points and using the slope formula. So that will include the formula. We will also look at a pair of slope word problems. And I will upload a Word document of those word problems typed out. And finally, remember I said there are 3 ways to graph. We already looked at graphing using tables and graphing using intercepts. Now we will look at graphing using y equals mx plus b, which is the slope intercept form. So let's get started. I'm going to jump around on this file that I've uploaded. This is the page 15. I want to talk about slope on this page here. So we know that you probably heard slope described as rise over run. Slope is also sometimes called rate of change. We're looking at linear equations here, meaning straight lines. In the ACM class, we don't really look at the U-shaped graphs or any of the more complicated graphs, just the straight lines. And slope means that the line goes up and out at the same rate. From any 2 points on this line, I should be able to count my slope, and the slope will be the same. So we count the rise, which is the change in y values. Up is positive, down is negative. And then this suggests that we always keep the negative sign with the numerator, and then we're always going to the right. And that's probably good advice. But again, slope is rise over run. In science and math, sometimes you see this triangle symbol to represent change. So it's the change in our vertical, our up and down, over the change in our horizontal. The horizontal change, which goes from left to right. It's important to know that a positive slope goes up from left to right. The terminology that Alex uses is rises from left to right, where a negative slope goes down from left to right. And the terminology that Alex uses is that it falls from left to right. And then it can be, the steepness of the line will vary with each slope. So for this example here, to kind of talk about, we see that we have 2 good points. Sometimes the points are given to you with these like big dots. Other times you just have to look and see where we hit an X and Y value on the grid kind of perfectly. We look at this point right here. Let me get a little closer. I look at this point right here, and I see that this is not a good point. It's not hitting this hash mark exactly. Neither is this point here. But At these two big dots, we are hitting the graph perfectly, hitting those cross sections. So from this point to this point, how many do we rise and how many do we run? I'm going up, which is in the positive direction where my y values are positive. I go up 2 units. Rise over run. So I go up 2 and then I go over 3. So we have a positive slope because we are rising from left to right of 2/3. Let me zoom out. So count from one point to another. How many do you go up or down? How many do you go left or right? Now, this idea about always keep the negative sign in the numerator, always run to the right. So that's good advice. But what if we didn't do that? What if I said we start at this point and we end at this point? Well, then I would go down 2. And if I'm going down 2, that's the negative direction. So that would be -2 over. So I go down 2, and now I'm going backwards or towards the left, which is the negative direction. -1, 2, 3. So if we go that direction, a negative divided by a negative, we know is positive. So it'll work out either way. We're just counting the slope. So we'll look at these two examples side by side on page 15. Finding the slope from from a graph. And so it looks like some of these points might be exact, but we don't know that they are. If you're given these two big dots, just use those. So from this point to this point, going to the right, I go down 1, 2, 3, 4. So I went down 4. And then I go over to the right 1, 2, 3. So again, if we go down where from the origin, if we go down, we're in the land of negatives. So that's -4 over. But from the origin, if I go to the right, that's the land of positives. So -4 over 3. Again, we see that the slope falls from left to right, so we know that it is a negative slope. Here, our slope is rising from left to right. Rises. So this is a positive slope. And if we count to the right, from this point to this point, how many do I go up? I go up 1, and then I go over 1, 2, 3, 4. So we rised 1, we went up 1, and we went over 1, 2, 3, 4. There are some questions in ALEKS that prompts you to create a right triangle to check your work, and that's what this was. We went up 1, over 4, and then the line itself makes the diagonal part, the hypotenuse. So that's finding slope from two points on a graph. I'll go to page 14 here of this document. And let's talk about finding slope from 2 points, not on a graph, just 2 given points. So here we use the slope formula. M represents slope, both in the formula and y equals mx+b. So here's the formula. You're going to use it a lot. M equals y2 minus y1 over x2 minus x1. Of course, you will have to reduce the fraction. if possible. So as we do this, the first thing you should do is label your points. These are two different coordinate pairs. We have an x and a y value and another x and a y value. Start by labeling your points. When I see students get this wrong on a test, almost always they didn't bother to label their points. This is my second x and my second y. You will get the same answer if you said like x2, y2, x1, y1. You do kind of have that option available to you. But I just go, this is my first x, my first y, my second x, my second y. What you cannot do is like mix and match. I see students say this is x1 and this is x2. That's all. That's not right at all. Ordered pairs are an x and a y. So then we just fill in the formula. On top, I have y2 minus y1, negative 2 minus 4. On bottom is x2 minus x1, 2 minus negative 3. So you just need to be careful with your negatives. If that trips you up, use a calculator. Let's look at using a calculator now. Negative 2 minus 4. Since this is my first term is negative, the first piece of this is negative, I need to use the negative sign, not the minus, but the negative. So negative 2, and now I use the blue minus button, 4. Negative 2 minus 4 is negative 6. And then I have 2 minus, parentheses, negative, here we go, 3. Again, this is a minus sign, this is a negative sign. 2 minus negative 3 is positive 5. When I was taught this in school, my teacher showed us that minus parentheses a negative easily connects into a plus. 2 plus 3 is 5. So that is our slope. That means we could plot these 2 points. To get from this point to this one, I would go down 6 and over 5. And then we could connect. So that's all it is, the formula there. We'll do one more, number 6 here. Dealing with a lot of negatives. x1, y1, x2, y2. So y1 minus, y2 minus y1 over x2 minus, because it's the minus from the formula, and then we have a negative 5. Negative 1 minus 7 is negative 8. And this is like negative 3 plus 5, the same as 5 minus 3, which is 2. Now this does simplify into negative 4. I don't think Alex cares if you put this over 1, but you don't need to. It's just negative 4. I don't think I can't remember, to be honest, if in this class you get the special cases. But we'll just look at this right now because it's not that long. What if we have something like this? x1, y1, x2, y2. So my y2 is 7, but my y1 is also 7. y2 minus y1, 7 minus 7. Over x2 minus x1. Well, 7 minus 7 is 0. 1 minus negative 3, or 1 plus 3, is 4. What kind of slope is 0 over 4? You don't have to memorize this. Just put it in a calculator. Anything, if 0 is on top, 0 divided by anything is 4. So 0 on top means the slope is just 0. 0 does not mean undefined. 0 is just 0. That means we have a flat horizontal line. No rise, all run. And in case it comes up, let's look at this one. x1, y1, x2, y2. So m for slope. We have our y2 minus y1 over, and then our x's are the same, 4 minus 4. -1 minus 8 is -9. 4 minus 4 is 0. And if we do -9 divided by 0, we all know what will happen. You cannot divide by 0. So just associate the error here with undefined. An undefined slope goes straight up and down. So 0 on bottom, the slope is undefined. 0 on top, it's just a slope of 0. So you have some word problems that you would probably like help with. And here it is. So I wrote these out, examples similar to what you'll see in Alex. But I will upload the excuse me, the Word document. So let's take a look. Similar to your number 12. Mango the cat weighed 38 ounces when he was 72 days old. Mango weighed 46 ounces when he was 82 days old. Fudge the cat, so a different cat now, weighed 36 ounces when he was 72 days old and 48 ounces at 82 days old. One thing that's important here is that time is always a function of the x. Time is always the x. So we need to find some information here. We've got 2 cats, and these are my 2 cats. Mango, little orange fella. And he weighed 38 ounces at 72 days old. But this is important because days is a unit of time. The day needs to go first. So these are the 2 bits of information for Mango. Again, our ordered pair here is days, because that's a part of time, and weight in ounces. So we need to kind of think about what is our ordered pair. 72, 38. And then he was 46 ounces. That's our y value because the days is our x. And then mango, nope, not mango, but fudge, my Siamese cat, weighed 36 ounces at 72 days old. So 72 days, 36 ounces. And then 48 ounces at 82 days old. So there's the days and the weight. Forgot to write what they actually asked us. But basically we'll find the rate of change for Mango. We'll find the rate of change for Fudge. And then who is growing fastest, I believe, is what we're looking for here. So slope, I think I said this once at the beginning, but slope and rate of change are the same thing. We think about rate of change when it's a word problem. So if we kind of graphed this, we would have, sketch out a little graph somewhere. So if we graphed this, we would have our days along the x and the weight along the y. And of course, these are both going to be positive values, so we'll live only in quadrant 1. I think you actually have a little graph on this problem. So what is the rate of change for mango? Well, we just have to label these like x1, y1, and x2, y2. So y2 minus y1 over x2 minus x1. And I would, in the calculator, if you're going to use a calculator, you do the top separately. 46 minus 38 is 8. 82 minus 72 is 10. And this simplifies to 4/5. In these word problems, they ask us frequently to kind of, interpret the meaning in the context of the question. So what this means, 4/5, that's the slope of mango, but what does that describe? That, since we're talking about days and weight in ounces, actually, should have put ounces, he is gaining 4 ounces every 5 days. So we'll look at the rate of change for fudge. For fudge, we have our x1, y1, our x2 and y2, kind of running out of room. But y2 minus y1 over x2 minus x1. So we put that in the calculator. 48 minus 36, we get 12. 82 over 72 is 10. Simplify that to get 6 over 5. So again, it's vertical over horizontal. That's how we can think about slope, or the change in our y over the change in our x. So weight is the y. So fudge is gaining 6 ounces every 5 days. So who is growing fastest? Fudge is growing faster at a rate of 6 ounces every 5 days. So you have to look at the information and find make your points. Identify that these represent ordered pairs. 38 ounces in 72 days represents an ordered pair. Use the slope formula, and then you just have to kind of think about it in context. Again, it's 6 ounces for every 5 days because it's rise over run when we think about slope, or the change in our vertical over the change in our horizontal. So we're really talking about, Vertical, that's our y. Horizontal, that's our x. So our y value was the weight. Our x value is the number of days. 6 ounces every 5 days. And number 13. This kilowatts per hour problem. So you are charged 0.031 cents per kilowatt hour plus a monthly fee of $11.85. I know that money is, to the second decimal place, but sometimes for something like a kilowatt hour, it's 0.031 cents. The total cost, y, depends on the number of kilowatt hours, x. According to the equation, y equals 0.031x plus 1185. And then it says that x is greater than or equal to 0 because we can't accrue a negative amount of hours. So the first parts of this, pretty straightforward. Determine the cost of using 1,000 kilowatt hours. So if you notice, it tells you what the ordered pairs are in the question. Kilowatt hours is x, cost is y. So we're looking at, I'll abbreviate, kilowatt hours for the x and cost for the y. So that means if it tells us to find the cost of using 1,000 kilowatt hours, we just replace x with 1,000. So 0.031 times 1,000. And then this 1185, that's like a y-intercept, and y equals mx+b. That's a one-time fee every month that doesn't change. I think in the question they called it tax, but it's a separate fee that does not depend on the number of hours. So we could put this in the calculator. 0.031 times 1,000, and then add 1185. And that's what we get as an answer. $42.85. You could do this all in one step if you wanted to, but I do it in two. Find the cost of 3,000 hours. Again, just do the exact same thing here. Just plug in 3,000. So why don't you pause and try to do that one? Did you get 104.85? And now we get into finding the y-intercept, finding the slope, and interpret its meaning in the context of the question. So now is a good time to talk about y equals mx+b. This is called slope intercept form, where m represents the slope and b represents the y-intercept. This is called an equation of the line. Your equation of the line will always have a y and an x in it. The only values that change are the slope and the y-intercept. So for example, if we had y equals 2x minus 5, our slope is what's in front of the x, just 2. A lot of students want to say 2x. That's not right. It's the m is what's in front of the x, not the x itself, just what's in front of the x. And the y-intercept here is a -5. So the last thing we'll do is look at graphing using slope-intercept form. But we need to recognize that this equation right here, y equals 0.031x plus 1185, follows the slope-intercept form. Forget about all the other information. If we just look at the equation here, we are in y equals mx plus b form because y is by itself. We have a value in front of the x, and we have a value on its own, no variable, being added or subtracted. So what represents the y-intercept? 1185 is the y-intercept. And what does that mean? Well, let's talk about that. When I'm on the y-axis, as we talked about in the previous video, if I'm on the y-axis, that's the y-intercept, where you have a 0 for the x value and then your y value. That's how a y-intercept works. So our y-intercept is B for y-intercept, $11.85, or 11.85. And what does this mean? Well, it means that x must be 0. So if I take this equation and I replace x with 0, it zeroes out this term, and we're left with just 1185. So that means if we use 0 kilowatts per hour, because the amount of kilowatts per hour used is our x. If we use 0 kilowatts per hour, we still have to pay the monthly fee, or cost equals $11.85. Because that $11.85, we are charged that regardless of the number of hours used. And then determine the slope and its meaning in the context. Again, slope is what's in front of the x. So here, slope for m is 0.031. And what does that mean in the context of the question? So in these linear problems, y equals mx plus b, the slope is 0.31. X is the number of kilowatt hours used. So we are charged 0.031 cents per kilowatt hour used. So let me know if you have any questions on that. And then finally, in this document here, I'm going to look at page 11, number 3. Let us now graph using y equals mx plus b. To do so, our first step is to plot b, the y-intercept. Plot the y-intercept, which is at -4, right here. That is my b value. M is, in this case, -2. Now, if we're graphing by hand, think about slope as a fraction, -2 over 1. So we want to plot the y-intercept and then just follow the slope. Your rise and run. If I go to the right, I can go, we know this is a negative slope, so it should be falling from left to right. And if we put the negative sign in the numerator, then we go down 2 and to the right 1. -2, so down 2 and then to the right 1. So down 2 and to the right 1. And I can keep doing that. And then we just connect. And a line should end in two arrows. If you're in Alex, you plot the points, and then there's this kind of like line tool. You have to plot the points and then select the line tool and connect your dots to make your line. Let's look at one more. Oh, a couple more on page 15. So that's plotting by hand. Just follow the... Oh, wait, I was going to do one more. I'm sorry. Back to page 11. That's right. I made this one. I did want to talk about this in case you run into a problem like this. You might wonder, where's the y-intercept? If there's no visible y-intercept, this is just y equals negative 2/3 x, then there's like an invisible plus 0 at the end. So that means our y-intercept is at 0. So if there's no b, nothing being added or subtracted at the end, then b is 0. And now our slope is negative 2/3. So again, plot your y-intercept and then go down 2 to the right 3. Down 2 to the right 3. If one of your points is off the line, if it's not going to connect, then that point is wrong. And now we'll go to page 15. So we looked at graphing using the y equals mx plus b. Now we're going to identify the equation of the line. The equation of the line is just y equals mx plus b from the given graphs. So we need to identify the b and the m. Because remember, every equation of the line has a y and an x in it. The only parts that change are the slope and y-intercept. My y-intercept is right here at negative 4. And my slope, to get from this point to that one, it's a positive slope because it's rising. I can go up 1, 2, 3, 4, 5, and over 2. So my equation of the line is y equals 5 over 2x minus 4. The only parts that change are your m and b. So one more, and then we're done with this video. I can see the line is going down, so that is a negative slope. I can see that my y-intercept is at positive 2. And then my slope, I go down 1, 2, 3, 4, 5, and over 1. So again, at different points, we think about slope as a fraction. If we're plotting by hand, I think it's better to think about it as a fraction. We don't need to put it as 5 over 1 in the equation of the line. I don't think Alex will care if you do, but the slope is 5, so 5x, and then plus 2. Again, positive 5 for the slope, positive 2 for the y-intercept, so, not positive, negative. My bad, y'all. Because it's a negative slope. So we go down 5 and over 1. So that's negative 5x plus 2. So I hope that helps. This is a long section, so let me know if you have any questions. And I'll see you next time.